Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I will be calculating the values for a DC parallel circuit from the Chapter 7 math handout, problem number 3. I'll begin by taking my known values from the Chapter 7 math handout, as you see here. So I'm looking at my Chapter 7 math handout. I go to problem number 3 and it shows what values I'm being given. So I take those given values and I enter them in to my spreadsheet. So I have all my resistances. It's a basic DC parallel, so every time it's a basic, you'll get all three resistors. Alright, so the first thing I want to do is find RT. I'm going to do that by using the reciprocal formula shown here. Sometimes it says REQ, sometimes it says RT. On different books you get different people say it different ways, but REQ and RT are used interchangeably. So I have all my resistances and my total voltage. I'm going to go ahead and calculate my resistance using the reciprocal formula shown here. So I begin by hitting 1 over under 1 over under 100. That's R1. Scroll over, hit plus, hit 1, hit over under. We're going to put the value of the second resistor, 220 ohms. Scroll over, hit plus, 1, over under 680 ohms. Hit equals, hit engineering, 62.43, but you got a 7 here, so we're going to round this to 44, rounding the second number after the decimal place. So my answer should be 62.44 ohms. So now I can fill in that blank. Okay, my next is to calculate IT. I look at Ohm's Law here. If I cover up the I can see that it is V divided by R. So here's my V of 50 volts over my R of 62.44. It equals, hit engineering, so it looks like I've got about 800.77 milliamps of current. So I can go ahead and fill that blank in. Now it seems like we would be kind of stuck here. We don't have 2 out of 3 anywhere, but if I understand my series parallel rules, which you will have to have this memorized for the test, if I understand my series parallel rules, I understand that on a parallel circuit voltage stays the same. So even though 50 volts was the only voltage value given on the Chapter 7 math handout, if you understand the rules, you can go ahead and make every one of these 50 volts. Alright, so now we can calculate I1 using Ohm's Law, cover up the I, V over R. So I1 is equal to the V of 50 volts over the R of 100 ohms. And that gives us 500 milliamps. Now I can do I2, which would be 50 volts over 220 ohms. So I'm going to leave the 50 in there, and I'm going to change this out to 220 ohms. It equals, hit engineering. So I2 is going to be 227.27 milliamps. And we can fill that in. Next is I3, 50 volts divided by the 680 ohms. And that gives me 73.53 milliamps. Alright, now I can do power using the power formula. You see the power formula here. If I cover up the P, which is what I'm looking for, cover up the P, it's equal to V times I. And that's why I always encourage you to write out these two circles for Ohm's Law and the power formula on your scratch paper. That's the first thing you should do when you get your scratch paper for a test. And then you can refer back to either one of these formulas that you need, either whether it be Ohm's Law or the power formula. And as I've shown you in class, there are a bunch of other formulas that we're not using for power and voltage and resistance and current, but we're just using the basic power formula in Ohm's Law. Alright, so PT is equal to IT times VT. Right here he covered up the P, so it shows you it's equal to V times I. So I have 50 volts times 800.77 milliamps. So let's put that in. 50 times 800.77 times 10 to the negative third equals 40.04 watts. Next I'm going to do P1, which is equal to I1 times V1. I've already got the V1 in there, so I'll just scroll up here. I'm going to leave the times 10 to the negative third and just get rid of the numerical value. And I'm going to punch in 500 milliamps. And that gives me a P1 of 25 watts. Next, I'm going to do P2, which is equal to I2 times V2. I've already got the V in there, so I just scroll up and I change the I value out to a 227.27 milliamps. This is my milliamps, and this is my voltage. When I'm looking for power, it's equal to V times I, V times I. That's what I'm doing right here. The V times the I equals 11.36 watts. Next is P3, which is equal to I3 times V3. I've already got my 50 volts in there. It's a milliamp, so I'm going to leave times 10 to the negative third, and I'm just going to change the numerical value to 73.53. And let me get this numerical value out of here, and let me put 73.53 times 10 to the negative third, 73.53 milliamps, times 50 volts. V is equal to I times V. Here's my V, here's my I. I hit equals 3.68 watts. A good way to check your work is power should add up. The 25, the 1136, and the 3.68 should add up to 40.04 watts. And IT times VT is also equal to 40.04 watts. So that's a good way to check your work. Add your powers up, see if they come to the same PT that you have. Then say IT times VT, run that through your calculator, and that should give you the same number as well. So a good way to check your work with power, just add these up. Take this one times this one, and that should give you the same number either way you go. Whether you add them up or whether you multiply these two, you should get the same number. If you do, that's a very good way to check your work. So let's check our work here. Let's add these up and see what it comes to. All right, so we got 25 plus 11.36 plus 3.68 equals 40.04 watts. So that's good. And if we take the 800.77 times 10 to the negative third times 50 volts, and basically gives me the same exact answer, which is, if I round, 40.04. So it is working both ways, and I checked my work both ways. Hope this video helps you out. Thank you.